Dear students, now we are going to discuss the practical examples of open loop and closed loop system. So in our syllabus, they given the four very important examples of open loop and closed loop system. The first thing is automatic temperature control in the HVAC system, and the second thing is cruise control in automobile, and the third thing is industrial process controller. So now we are going to discuss the first thing is automatic temperature controller in HVAC system. So now see here that automatic temperature control in the HVAC system is a closed loop control system. It maintains the indoor temperature at the desired set value automatically using the feedback. So see here, the first thing is that room cabin temperature that we are setting the reference input. The next thing is the temperature control we are having in the controller part. And the devices we have heater, expansion valve, condenser fan, and so on. And the next the output is room and cabin temperature. So now the output part will be through the temperature sensor. It feedback to the temperature load part. That means we are having that error detector part. So now this feedback temperature value will be compared with that reference input we are setting as room and cabin temperature. So if any corrections are there, the temperature controller will be automatically adjust and maintain the indoor temperature at the desired set value. So now see here, this is the another type of the error control. So now the desired output we have in the comparator and the error signal, based on that it will be maintain the desired temperature value. So here the working principle is the first thing, the desired temperature is set on the thermostat point. The temperature sensor measure the room temperature. The controller compares the actual temperature with the set point. And now the HVAC system heats or cools the air until the error becomes zero. So now here the control type is closed loop and the control variable is room temperature. And what are the benefits means energy efficiency, maintain comfort automatically. The next thing is the next example is cruise control in the automobile. So here the control in automobile is used to maintain the desired speed in the vehicle. So the same concepts only. So here, but the parameter is speed of the vehicle. So for the first, we need to set the reference input is desired speed. Next, we are that particular input will be going to controller and throttle unit and engine. So based on that output speed, the speed sensor will be giving the feedback signal to the error controller part. So it will be compared with the desired speed. After that, it will be automatically adjust with the controller part. So these are the system in the cruise control system. So here, based on this operation, it maintains the constant vehicle speed set by the driver without continuously pressing the accelerator pedal. That is the main purpose here. So here the working principle, first the driver sets the desired speed, and speed sensor measure vehicle speed, and controller compares the actual speed with the set speed, and the throttle position is adjusted automatically. So here also the control type is closed loop and the control variable is vehicle speed, and the benefits is reduces driver fatigue and improves fuel efficiency. And the next application is industrial process control. So here the industrial process control, we can control any parameter. So here it may be chemical or it may be pressure or any industrial parameters we can take in here. So here also the same thing. We can do monitor and regulate the optimized industrial process by we are keeping the reference value, some desired value you can keep it up. So now see here that the input that will be going to controller, then the next the activator, and again the feedback path will be going to the error detector. So it will be check the desired value. So here the variable control you may take an temperature, pressure or any concentration parameter. So here the sensors continuously measure the process variable and the controller regulates heaters, coolers and flow rate. So here the what is the importance of this industrial process control? We can ensure the safety and improves product quality. So now see here that the real image of this industrial process controller. So based on the desired value, the valve will be closed automatically. Now the next fourth application is conveyor belt systems. So it is used to regulate the speed and direction or operation of conveyor belt to ensure smooth, safe and efficient material handling. So now see here that based on this control circuit we can regulate that. So here the speed position is monitored using the sensor and the controller automatically adjusts the motor speed and maintain uniform product flow. Now what are the importance means here it will be prevent overloading and also increases productivity. So these are the real-time application of conveyor belt. See here, so based on that each stage there is some controller valve is there. So based on that we can maintain the desired speed. Thank you.